is a flip video about the ideal gas law. So before we talk about what the ideal gas law is, let's take a look at this picture, which is just a container full of gas. So the black container is outlined here, and the blue little particles you see here, the blue little dots, represent gas. And if you notice, I've drawn these little red arrows, kind of to indicate that gas is always moving around. And the most important thing to know about gas is that gas hits the walls of the container and each other. And this hitting the walls of the container is pressure. If the gas never hit the walls of the container, then you wouldn't have pressure. So remember, we talked about pressure is force per area. So that's important. So what are some variables that we can look at when we talk about a gas sample? Well, hopefully you've remembered all the ones that we've seen before. And first of all, we just mentioned pressure. So for our ideal gas law, it's important to have pressure in ATM, atmospheres, which is the unit. What are some other variables we can look at? Well, we could talk about the volume that this gas is taking up. So volume. And again, let's make sure that we keep the volume for ideal gas law in liters this time. Okay? Hopefully you also remember temperature. Temperature is important. And again, in all of our gas laws, temperature must be in Kelvin. And the last variable, pressure, volume, temperature, is a new variable, and that is all of the gas particles represent the sample. So if I had more gas, how would that look in here? So if I started adding more gas, what would that do? Well, that would make it really crowded in here, and therefore there would be more collisions. Okay, so that would do things like increase the pressure. So more gas is a variable that can affect things. And that's one of our new variables today. And so your number of gas particles is measured in moles. Okay? And your number of gas particles is represented by the variable N. Remember, P stands for pressure, V stands for volume, T stands for temperature. Those are easy. But your gas particles, that's N. And it needs to be measured in moles. So we look at how many moles of gas we have in here. We don't count them up because there's so many gas molecules. All right? Well, good. All of these variables are what we're going to be looking at today in the ideal gas law. And the ideal gas law puts them all together. If you notice here, this is the equation we're going to be using. It's P times V, so there's my pressure, my volume, equals N, which is my new variable, my gas, amount of gas I have, right? That's another way of saying it. Number of gas particles, also amount of gas, times R, which, hold on for a second, I'll tell you what that is, times T, which is temperature. These are the units they must be in for this gas law and this gas law only. Okay? All right, so let's go back and talk about what this R is. R is a new thing also for the ideal gas law. And all R represents is R is a gas law constant. Again, here's that R. It's going to be in our ideal gas law equation. PV equals N times R times T. So all these get multiplied on this side, all these get multiplied on this side. Don't forget the equal signs right there. This is the R we're talking about. It's just a constant. And in science, a constant is a number that stays the same. So no matter what happens, pressure up, pressure down, volume up, volume down, and so forth, this R will always stay unchanged. It'll stay the same. And so what is that constant? Here it is. There are many different R's, but for our sake, no pun intended, R, we are going to be using 0.0821. This R has a unit, and this is it right here. This is the unit. Liters times the ATM divided by moles times K. This, again, is the unit attached to 0.0821, right? Just like we have something like 12 inches. Inches is the unit. This number has a very chunky big unit. This is the unit, so we do not plug anything into this. This is not an equation. This just gets tacked along. It's not an equation. Do not plug in anything here. Sometimes students accidentally plug things in. It's just the tail end of the number. It tells you what the unit is. Okay? So if you notice, let's bring back our variables. We said pressure has to be in ATM. Check. Got it. Volume has to be in liters. N has to be in moles. R we know is our gas law constant. This will always be given to you. And T stands for temperature in Kelvin. Well, ATM, liters, moles, Kelvin. R shows us all the units that the other variables should be in. Kind of a nice, easy way to remember what units I should have. Okay? This, though, is the equation we're going to plug it into. Not this. This is not an equation. Okay, so if you see here, we're now going to be given problems that just have a pressure or a volume or moles or temperature. We're not going to be given initial and final conditions when dealing with the ideal gas law. They're just going to be conditions. And what's going to happen is you're going to get maybe 3 of these conditions, and one of them is going to be what they're going to be asking you to solve for. So maybe they're asking you to solve for pressure. Therefore, they'll give you volumes, gas particles, and temperature. You always plug in the R because you have it. Or maybe they're going to be giving you having you solve for temperature, so they'll give you the other ones. Okay, just as a matter of what the question's asking for. Again, the new things are right here. N and R. Those are your new things. Make sure that you point those out for yourself. Okay? Good? So another way to write this equation, just so you know, is this right here. Hopefully this makes sense. I just took out the multiplication, so P times V equals N times R times T, so PV equals nRT. Sometimes we call this the Pivnert equation because it sounds like Pivnert. Pivnert. Okay? All right, so here are some things we should remember before we get into our problems. Let's see here. Remember, temperature has to be converted into Kelvin. There's the conversion, degrees Celsius plus 273. Pressure must be in ATM, so don't forget you have pressure conversions. Look them up back in your notes. You might have to convert your pressure before you begin. Also, if volume has to be in liters, you might be given milliliters. You must convert for the ideal gas law. 1 liter has 1,000 milliliters in it. So remember, you have to have liters for ideal gas law. All of the other equations, it doesn't matter. And last but finally, 1 mole equals the mass in grams in the periodic table. Why is that important? Well, I'm going to tell you. They're going to try to trick you. And they're going to give you grams of a gas sample. If they give you grams, remember, you have to convert that grams into moles. You just have to read your problem and see what they give you. So let's begin with this sample problem right here. 2.3 moles of helium gas are at a pressure of 1.70 atm, and a temperature is 41 degrees Celsius. What is the volume of the gas? So now, if this problem didn't say use ideal gas law, here's what you should do to see that that is the law you should use. You should always list your variables, okay? I have 2.3 moles. Well, I know N represents moles, so 2.3 moles. And the pressure, P stands for pressure, is 1.70 atm. And I have a temperature, which is 41 degrees Celsius. Right away, I convert that to Kelvin, so 273, right, should give me 314 K. Okay. So that's more important than the degrees Celsius. And what is the volume? So V is question mark. All right, now I look here and I say I have P. I'm solving for V. I have N, T. I don't have any initial and final conditions. I just have one set of conditions. That is the ideal gas law. P, I'm solving for V. I have N, and I have T. Right? Anytime you have N, right away you should think of ideal gas law. So what happened to the R? Remember, you always get R. It'll be given to you. You're the one who has to put it in, right? You have to remember to put it in. They won't tell you, remember R, you have to remember it. So here it is, and don't forget that unit. Okay, now I'm ready to begin. So, I want to make sure that I followed all of my correct units. To use PV equals nRT, my N has to be in moles, and it is. Check mark, good. My P has to be in ATM, and it is. If it wasn't, I would convert. My T has to be in kelvins, I already converted. My V is naturally going to be in liters. And my R, well, I just copied it down, so it's all good to go. I am now set to go. If I wasn't, I'd have to first show some conversions. So let's begin. PV equals nRT. I'm solving for V, so let's do a little algebra. Let's get V all by itself. It helps if you move the variables around before you plug things in. So to get V all by itself, I have to divide both sides by P. P cancels out here, P cancels out here. So V now is equal to nRT over P. There we go. There is my equation. Again, it helps if I move the letters around first because as you see, I've got a lot to work with. Okay? So now V is equal to, so I'm going to plug in my N, 2.3 moles. Don't forget your units in your work. R is equal to 0.0821. And now, copy this entire unit. This will be given to you, but it won't be told when you should use it. Moles times K. Don't forget all of your units. And my temperature goes up on top. My temperature was, let's bring that back. Here it is, 314 K. Divided by, and on the bottom goes just my pressure, 1.70 ATM. Don't forget your units. Now, this is really important, and I'd like you to do this. I'd like you to cancel out any units you can. So first I'll have ATM here and an ATM cancel here. Now, if you notice, my R has units on the top, numerator, and units on the bottom of a denominator. This moles and this moles can cancel out because this technically is on the denominator. This K and this K can cancel out. I'm left with liters, which makes sense because volume has to be in liters. So now I'm going to solve. And as I solve, so it's a good time to pull out your calculator. I'm going to do 2.3 times 0.0821 times 314 divided by the 1.70. This is the time where you show me that you're following along and put this down on your paper. How about sig figs? Well, I want to go with the least. When I multiply and divide, there's 2 sig figs here, there's 3 here, there's 3 here. Remember, we don't look at constants or givens, okay? 2 is the least amount of sig figs, so when I get an answer, it should have 2 sig figs, and the unit should be liters. There you go. That's how you solve for these problems. Now, I want to say one last thing. This N, sometimes in the problem, instead of saying 2.3 moles, they may say something like you have 5 grams of HE. If they say something like that, your first step is to take your 5 grams of helium and convert it. Remember, 1 mole of helium is equal to the mass on the periodic table of helium. Now you're ready to go with moles. That's something you want to make sure you're careful of and that you remember. Make sure you make a note about that. That's the end.